Make today matter.
Welcome, good evening, and thank you for being here in such great numbers. It is wonderful to see so many of you here this evening, where a very pertinent topic on the fourth industrial revolution will be presented by Dr. Arora, where Dr. Arora will unpack the idea which Prof. Klaus Schwab presented at the World Economic Forum in 2016. I think there can be no better occasion than at the Hendrik van der Bijl Memorial Lecture to do this, who, as a proud son of South Africa, was pivotal in establishing the foundations for the industrialization of South Africa. As Dean of the Faculty of Engineering, Built Environment and IT, it is indeed my honor and pleasure to welcome each and every one of you this evening to this, the 54th Hendrik van der Bijl Memorial Lecture. And we at the University of Pretoria are very proud to be partners with the South African Academy of Engineering over the last 53 years to successfully host this very important and momentous occasion where we reflect and look forward onto how we can take South Africa forward into an industrialized nation. Distinguished guests, please join me to welcome Professor Cheryl Delaray, our Vice Chancellor and Principal, to address you and introduce our keynote speaker, Professor Delaray.
Good evening, ladies and gentlemen, and thank you very much to the Dean of the Faculty of Engineering, Built Environment and IT, Professor Maharaj. I too am delighted to welcome all our guests on the occasion of our annual Hendrik van der Bijl Memorial Lecture, which, as you already know, is arranged under the auspices of the South African Academy of Engineering and the University of Pretoria. I too am especially pleased to welcome the President and representatives of the South African Academy of Engineering. Dr. Gorba, welcome once again. It's a pleasure to work with you and your office. The former Vice Chancellor and Principal of the University of Pretoria and the University of Hull in the UK, Professor Kali Pistorius, welcome back to your university. Chief Executive Officers, representatives of industry and government departments, Vice Principals and Deans and executive members of the university, colleagues, students, and of course, alumni. Our distinguished speaker I shall introduce in a short while, but a very special welcome to him, and thank you very much for accepting our invitation. Yesterday, as a nation, we South Africans celebrated Heritage Day. The key message from our President and Deputy President of South Africa called on us as South Africans to remember the legacy of the founding president of our democracy, Nelson Mandela, who at the time called on all South Africans to unify in our diversity and to see diversity as an asset to be harnessed for the advancement of our nation. This annual memorial lecture is also a celebration of our heritage, particularly the exceptional legacy of Dr. H.J. van der Bijl, who was instrumental in laying the foundation for South Africa's industrialization in the 20th century. Hendrik van der Bijl was born in Pretoria in 1887. Exceptional for his time, he obtained a PhD specializing in electronics at the University of Leipzig. His successful research led to an appointment as instructor of physics in Dresden in 1912, and soon thereafter he was invited to join the American Telegraph and Telephone Company in New York, where he became one of a select group of research scientists who spearheaded the American technological development at the time. In response to a call by General Smuts, van der Bijl returned to South Africa in 1920 as technical advisor to the South African government. In brief, his leadership led to the establishment of what we now recognize as Eskom, in the past ISCOR, the IDC, the SABS, the CSIR, SAF Marine, and of course, the Van der Bijl engineering legacy. In no small measure, the foundations for the industrial development of South Africa were indeed laid by this exceptional individual, the scientist, the industrial leader, the engineer, and the entrepreneur. His achievements have been recognized internationally and locally. For example, he was elected as a Fellow of the Royal Society, and he received honorary degrees from the University of the Witwatersrand and Stellenbosch University. His role and influence was also in academia. He was always highly conscious of the need for tertiary education, particularly in mathematics, the physical sciences, and technology. And it was this commitment that brought his close association with the University of Pretoria. Dr. van der Bijl was Chancellor of the University of Pretoria from 1934 to 1948. Amongst others, he was instrumental in conceptualizing and financing the chemistry building at UP, towards which he made a personal contribution. Given that yesterday was Heritage Day, I believed it's apt to note the perspective shared by Dr. Hendrik van der Bijl in the closing words of his inaugural address as Chancellor of the University of Pretoria many years ago. He said, "To cement together, by common endeavor for achievement, all the peoples of South Africa, regardless of race or creed, into the brotherhood of mutual trust and goodwill for the welfare of our country." Cementing together for achievement the peoples of South Africa is what the University of Pretoria continues to stand for. We believe that diversity is an asset to our institution and to our nation, as did Dr. van der Bijl. This annual lecture is intended to draw our attention to the extensive contribution of engineering to our national social and economic development. Dr. van der Bijl's legacy continues to be a source of inspiration for the University of Pretoria School of Engineering, which in 2016 celebrated its 60th anniversary. Today, under the leadership of Professor Maharaj, the University of Pretoria School of Engineering leads the country in terms of student numbers and graduates. Over 25,000 graduates since its inception, and it is home to the widest range of professional engineering degree disciplines of any engineering faculty in South Africa. Since 2010, the School of Engineering has regularly produced in excess of a quarter of all professional engineering degrees in the country. And here we compare ourselves to only 7 engineering degree awarding institutions in South Africa. This is a contribution of which we're extremely proud. In keeping with Dr. van der Bijl's spirit of innovation and paving the way for South Africa's economic and industrial progress in the previous industrial revolutions, it is highly relevant that the 2018 Van der Bijl lecture tonight is focused on the 4th Industrial Revolution, specifically on digital transformation, which, from the perspective of our guest speaker this evening, offers us an opportunity to reposition our local imperatives. And given the conversation and the speeches and the sentiments expressed by President Ramaphosa recently, we urgently need to reposition our local imperatives. As Prof. Maharaj has alluded to, the 4th Industrial Revolution has been described in many ways. One of them is as the advent of cyber-physical systems involving entirely new capabilities for people and machines. For some, it offers great promise, and yet, for others, it is true that the complexity of these technologies and their emergent nature generates a feeling of fear and threat. Although many talk about the 4th Industrial Revolution as something that is coming and that we need to face in the future, I wish to remind us, because I think it's appropriate, of what the novelist William Gibson famously said: "The future is already here." It's just not very evenly distributed. With these words, it's now my pleasure to introduce this evening's esteemed speaker. Since 1993, Dr. Gustav Roeder has been the Chief Operating Officer and Executive Member of Oricon, a global engineering and infrastructure advisory firm. He manages all aspects of project delivery as Oricon's COO, including financial, operational, and people performance to meet the strategic business goals. Very briefly, he completed his undergraduate and honors engineering qualifications in South Africa at the Universities of Stellenbosch and Pretoria, before attaining his master's in engineering and subsequently his PhD at the well-known Texas A&M University in the USA. He is, of course, a fellow of the South African Academy of Engineering. His career has spanned continents. He began his career as a junior engineer with Van Wyk and Lowe in 1985. After a stint as a researcher at Texas Transportation Institute and then at FHWA in Washington, he rejoined Van Wyk and Lowe from 1990 to 1994. In 1994, he was appointed as director at what was then Africon, working his way to managing director of transportation and subsequently CEO. Under his leadership, Africon grew to 16,000 employees in 14 different countries and became the only South African-owned consultancy to be named in the International Engineering News Record Top 200 list. His work experience is extensive at various levels. It spans road rehabilitation, feasibility studies, materials, infrastructure, asset management, and he has worked on projects, as I said earlier, on a number of different continents. Goes without saying, in South Africa, the USA, Malaysia, the Philippines, and in many African countries. He also has an impressive number of international technical publications to his name and extensive local and international experience in the design, construct, and maintenance aspect of transportation infrastructure. With this short introduction, I've convinced you that tonight we have the opportunity to learn from an experienced expert. Dr. Roeder, it's now my pleasure to welcome you to the podium to share your insights and your experience of the fourth industrial revolution, digital transformation, and opportunity to reposition. Thank you.
Cheryl, thank you for those kind words. Good evening, ladies and gentlemen. It's indeed an honor to talk at this memorial lecture, and Cheryl has done a good job of explaining what the heritage of Dr. van der Bijl. One of the interesting things that's not documented in your piece there is that I saw when he created Eskom in 1923, he went to the then Jan Smuts, who was the leader of the country, and he asked for a 16 million loan from government. And Eskom repaid that full loan in 10 years because he believed that utilities like that should be self-sustainable. Today, 16 million is nothing, but that was an interesting comment. What I'd like to talk about is the fourth industrial revolution, and I decided to tackle it in 4 ways. The first one is I'd just like to common base everybody about what it means, what it implies. Then I'd like to give you some examples of recent things that we're seeing in industry, and I'll just show you examples of recent technology impacting our industry. And then I'd like to move on towards how I actually see it impacting the engineering industry, the type of skills we're going to need in the future, the way we need to train our young people, the way we need to restructure our businesses. And then I'll end up with a conclusion whether I see it as an opportunity or a threat. There's been four industrial revolutions. In short, the first one, you can see the dates there, the late 1700s, mechanization, around 1900, mass production, 1960, for the next 15 or 20 years, it was all about computers and automation. And the current one is about connecting the whole world of physical and cyber systems. And it's all about these aspects of robotics, the Internet of Things, cybersecurity, system integration, 3D, all of these things that's coming our way. Now, there's an interesting YouTube, and I'll give you the reference at the end, by Tony Seba, where he shows in the previous industrial revolution, or the second one, how quick things happened. And he's got in his talk, he's got two photographs. This is in 1900, the Fifth Avenue, New York. And he asked the audience, please spot the car. And you can see there's actually only a single motorized vehicle in 1900. And then he's got a photograph 13 years later, 1913, and he asks, where's the horse? And there's only one left. Which gives us a feeling of how quickly these industrial revolutions change and the speed of change. And one of the things that we currently experience is that this fourth industrial revolution is coming at a much faster pace than what we saw here. And it's impacting much more than what we saw in the previous industrial revolutions. I look at my own career, and when I was the first 2 years at university, we were forced to use logarithmic tables. I look at the audience, there's a few of you that shared that experience with me. And the last 2 years, we started a fantastic programmable Hewlett-Packard 41C. I started work, and this was the mainframe in our offices. Late 80s, this was a 286, my first PC, laptops. And today, what's interesting, a single photograph on an Apple phone is bigger than the memory of that computer system. All right, so this is, and that happened in my lifespan or my career. We used to have Ponskaarte to run computer programs, floppies, stiffies, sticks, and today we're talking about putting things in the cloud. And I think all of this happened in most of your lifespan. There's Moore's theory that was defined probably around somewhere here, and it says that computer speed doubles every 2 years. And for the last 50, 60 years, it's actually achieved that, and one can see the processing speed. I put my career on there. I've been an engineer for 33 years. That's the span of my career. And I'm starting to think, and I see there's some young people in the audience, your career is going to be here. And at the moment, processing speed is such that it's probably about the speed of a mouse brain, and up here is the human brain. Just giving us a feel of what's ahead and the speed of how this is changing. There's an African quote, this is out of West Africa, say, if the rhythm of the drum's beat changes, the dance steps must adjust. And I think this is absolutely true for this revolution that we're facing. It doesn't help you go to a dance and you do a two-step and they changes the music to a waltz. And that's what's happening to us. The beat is changing consistently. And I like the title, this is of an ex-South African, wrote the book Dancing with Disruption, which I think is what we're in for. Those that cannot change and pick up the beat in engineering space is going to be obsolete. I'm personally convinced of that. Now, this whole thing has got good and bad news for us. This is a pictorial from McKinsey's in 2015 showing various industries and how affected they can be by a digital disruption. And I've marked down here, I'm from the infrastructure or construction fraternity, we're right here. There's only one area that's slower than us, that's agricultural and hunting, which is right at the bottom. So my industry will be seriously disrupted. And I realize that in the audience there's engineers from different disciplines. I mark them. I think we're all in for quite a disruption. And my own philosophy on this is, let's not see it as a disruption, let's see it as an opportunity, if we can change our beat of the dance. I want to show you a number of digital developments. Most of them, unfortunately, would be out of my industry, which I'm familiar with. But I'd like you to also think about your own space, because many of these things is also relevant to other engineering areas. First, a bit of finding common ground in the audience. They throw around the words of digitization, digitalization, and digital transformation. Basically, the difference is that on the far left, digitization is just making sure a computer can understand stuff. So it's putting it in some digital form. Digitalization is automation of processes. So it's automation and these things. And then digital transformation is the process of devising new business applications. That's all encompassing. And I believe that we've got an opportunity. Don't stop here, don't stop there. Really go for digital transformation. And some of the examples I'll show is in our industry, when we start doing designs, it's all in 3 or 4 or 5 dimensions. It doesn't help that we don't also change the way we design and restructure our businesses to take care of that. So it's about all 3 of these aspects, and really the challenge is that it will affect everything we do. Some of the digital developments, and I'll just run through a whole series of different things to give you a spiel of the things that's happening in our industry. It's all about geolocation, tracking, spatial measurements. These days, the days of doing surveying is gone. We send up a drone and we do laser scanning. And you can actually go into a building like this and put a little device here, and it'll scan the whole building, and within a few minutes you've got a scan of every element in this wall. So that's changed drastically. Now, just as a matter of interest, our universities hasn't caught up. They still take youngsters for 6 months of doing surveying with equipment that we don't use anymore. And that's the type of rapid change that we've got to face. BIM, Building Information Modeling. This is all about putting and designing in virtual space. Half or 3/4 of my career, what we did is we designed in 2 dimensions on pieces of paper. And for the last decade, and it's rapidly changing now, everything is in a virtual model. A good example I have is this is a project that we've done in Macau. It is a 50% replica of the Eiffel Tower.
Macau Eiffel Tower forms part of the Parisian Macau, an integrated resort by Sands China Limited. The Macau Eiffel Tower, which is half the size of the original, is a faithful replica of the famed 19th century counterpart in Paris. Oricon provided the drafting of the tower using Revit software, which allowed the team to visually represent the complicated design connections in 3D. The 3D structural animation here gives a simple demonstration of the visual representation. The project topped out on the 15th of October 2015.
That's the completed product. And what's interesting is they went back to Eiffel's design books, which you can buy, and they actually put it all into the computer model. Eventually, it had to be done that way, because you can imagine that to just look at the structure here. As an example, this is the real built one, and this is the 3D model. Just look at the complexity of the structure. And every bolt and every joint has been coming out of the model. There's another one, you can just see there's the current structure, and this is in the 3D model. And there's another one. So this is the way we currently design in 3D in a model, and that has a lot of advantages for the whole construction industry, because each one of these things can be manufactured using exactly the same 3-dimensional computer model. We also start to talk about the 4th and 5th dimensions of design, and a good example that I'll show you here, this is in California, near the Bay Bridge, and up here is the first 3 dimensions. So it's the coordinates of every element in the road design to the nearest millimeter. And then the 4th and the 5th dimension is cost and schedule. And I'll press the button now, then you can start seeing it's mimicking. So you can see up here in time how it's running through the S-curve of construction. And up here one can see every element here has already got a cost element to it. So we're starting to integrate all of these things. And by the way, this is fantastic for a constructor or a contractor. And by the way, this is already probably 3-4 years old. So this is not state-of-the-art stuff. This is the way we work today. The next digital development I'd like to touch base on is it's having big impact on collaboration, integrated design, workflow, and project management. The best way I can explain it is just look at the life cycle of infrastructure. So we currently design in this virtual model, and let's start with conceptual design, detailed design, and analysis. Gone are the days where different individuals do it and they integrate it later. Whether you're the architect, the civil engineer, mechanical, electrical, or structural, all of them are working in the same virtual model that's currently housed in the cloud. All right? And obviously huge advantages of doing that. But that's not where it stops. It goes through the whole life cycle, because that same digital model can be used for documentation. It's used for fabrication, because every element that you designed in here, whether it's mechanical, electrical, already can be manufactured from that same piece of information. And we can take it through to the 4th and 5th dimensions, which is about putting price and time to it, constructability, logistics for contractors. And then what's also fascinating is it becomes the model for the life cycle of infrastructure. Because we might think about a building like this and it's expensive for first cost construction, the operational and maintenance cost of infrastructure is usually much more expensive than the first cost. And all of this stuff that came in there during design is actually exactly the information that one can carry through the life of the infrastructure for the next 40 or 60 years. And then obviously you could take it through to the full life cycle of renovation. We're currently involved in this stadium. This is in Qatar, the Lusail Stadium. That's the next Soccer World Cup stadium. And there's 150 professionals working on this design out of 17 different offices. And the whole digital model is in the cloud. I still don't know whether that's above Singapore or somewhere in the USA, but it's in the cloud. And they all work in the same space. Now, another interesting thing for me on this one is that just imagine the engineering challenge. We've got to, the specification requires a 25-degree temperature at grass level, at playing level. So HVAC in the middle of the desert is a huge challenge. And then obviously this structure and this roof is absolutely critical and challenging. The highest paid professional on this project is not the structural engineer or the HVAC specialist or the project manager. It's the owner of the BIM model. That's the highest paid professional on this project, because that becomes so critical and so important. Let's move to big data, advanced analytics, and artificial intelligence. And that's now in the next phases of starting to use information to take intelligent or get it intelligent. A good example that I've got here is, this is the aerial photography or satellite photography from the city of Cape Town. And they've got a management system that determines which of these streets has got to be paved or resealed. Historically, up to 2 years ago, we had to go out and measure, with a tape measure, the width of every piece of road to calculate the surface area of asphalt, surface area of what has to be resealed. There's 2 young people that wrote a little app for us that now takes the satellite photography and calculates the width of the road. So physically, it takes these pixels, look at the color, and does pattern recognition, and then starts saying, well, where's the edge of the road? And you can see there, I'll stop it now. It actually goes through and it says all of these pixels, what's the probability of it there being a road or not? And at the end of the day, so the whole city of Cape Town is now done by a computer instead of sending out 3 technicians measuring the road for 3 months. All right, the other huge development is obviously in the Internet of Things. Everything is becoming connected. This is just some photographs. This is Wynyard Station in Sydney, and the whole thing is monitored. Whether it's the HVAC, the temperature at the terminals, every passenger can see when the next train is arriving. They can even tell which coach on the train, how many people there is on a coach. They know what bus to take, etc. So all of these things are starting to become fully integrated because the internet allows us and the easy way of monitoring things. Another interesting space is virtual and augmented reality. And I see they also now talk about mixed reality. So it's about different applications to start visualizing what you see in this computer model. So here we've got an example. This is in Christchurch, New Zealand. This client is actually traveling on the design of cycle paths through Christchurch to be built. Because in his visual mask, he can actually see, as he's pedaling, what's to be constructed. There's an example here. This is, again, a cycle path to Sydney Harbour Bridge. All right, so, and I'll get to a point where I see the big advantage here. Probably for an engineer, this is not that cool. I can see it in a diagram. But for a client and to interface with communities, there's huge advantages of starting to use augmented reality or virtual reality. Here's an example. Easy nowadays, if you've done a design in that three-dimensional model, it's possible to actually go through it and see where you're at, see what you like, see the colors, see the potential of the building or the facility or any piece of infrastructure, by just navigating yourself through this and in this virtual tool that's connected to the computer. This is just an example of virtual reality again. And these are two young engineers looking at the model. This is actually, we just put it there, but they're actually discussing it, they're pointing at nothing. But in their glasses, they're actually discussing the design. All right, the next area is digital twinning. So what's happening is that, and twinning is about building for reality a virtual twin. And one can see different examples in different industries. For example, vehicles are now being tracked. Every moving part through the internet, you've also got a virtual model of a piece of equipment. So for example, Bijl would be logging all of their construction vehicles out in operation on a mine, all the way from the States. And they know every part, when it's in need of maintenance, etc., and how it's functioning. We've got exactly the same for the human body, where one can actually build a computer model and see how the human body reacts. Systems can be the same. And in our space, we're doing a lot of things in terms of intelligent cities, to start monitoring what's happening with a building, etc., in a computer model. I'll show you this one. This is our Sydney office, and we had two young professionals came in over a weekend and surveyed this whole building. It's a little device, you put it down and it surveys every room. And then they built a model, and they put in what they call 60 Raspberry Pis. It's little devices that measure humidity, temperature, movement, etc. And I'll show you in a moment what happened there. So this is the three-dimensional model of our office. And it's possible there you can see some of the gauges, measurements in that specific area there. And we can do light, movement, people moving around, humidity, loudness, and this is 60 sensors that's right through that building. And the next thing is this is then connected to a clever system, because you can switch off lights where there's no people. Or you can up the aircon in places that's too hot. Or you can put it off in places where there's no activity, etc. So the whole world of clever buildings is coming out of all of this stuff. And it's so easy. Actually, that's the little device that we put 60 of them right through the building. So nowadays, when you design a building, we talk about the intelligent design. The days of just doing a construction without it putting some cleverness in a building is way over. The whole world of cybersecurity is obviously a big concern. 3D printing and scanning is another fascinating space. It's exciting to see that just 5 kilometers from here at the CSR, this is an article from July stating that it's the biggest 3D printer in the world. This is a bridge in Belgium that was printed in a printer, concrete printer. And this is a young student at Stellenbosch who's busy he did his masters. Obviously, I fast-tracked that. They don't work that fast at Stellenbosch. What is fascinating, this young person built his whole, and that's the whole printer, all of the electronics, the pumping stations at the back for 90,000 rand. And the challenge now is not the printing, it's the material. It's the concrete. That's the challenge. So just an idea of free printing, and worldwide there's lots of activities of this. The global contractors have got huge printing machines now. Printing and prefabrication, big parts of construction. Intelligent systems, smart buildings, smart cities. I said already, this is a building today or the future. It's monitoring everything from light to HVAC to fire to security, people moving through the business. It can give you access to different parts of the business, etc. And all of this can be centrally managed. And interesting enough is you guys must hear a lot about smart cities. I think currently the focus is on getting connectivity to cities. The big engineering challenge is going to be to do something with that connectivity, whether it's intelligent cities or putting engineering skills into the infrastructure. There's lots happening in robotics, especially in the manufacturing side, also now in construction. This one I found interesting. That's opened in the last 6 months in California. It's a shop where you actually ask the computer to do a cappuccino or a latte or whatever, and it actually do the perfect cappuccino, pass it out to you, and then it finishes by saying goodbye. I still wonder whether it's not better to have a human body that asks you, how's your day, and mean it. All right, so area of drones, big difference in the construction industry. Just a quick video here to show you. So in terms of construction monitoring, we now fly sites often to have a record of what's done. And I'll just move to the next one to show you what we do with this. Now that's that same area, and what's done then, traditionally if we had to calculate how many cubic meters of crushed rock is in this stockpile, you had to send somebody out. It'll probably take a day to do surveys. You come back to the office and you've got to calculate with cross sections, you quantify how many crushed rock is in that stockpile. Now, this is what happens today. So they go onto the computer, they quickly click the item that they want the volume from. And up here you can see the outcome, 210 cubic meters of crushed rock. That's probably a morning's work instead of 2 days, 3 days. And that's a simple example. You can do many, many other applications. Here's another one, which is, again, something that we've done in Christchurch, some rock mapping. And this is at the earthquake site. So one can see over here, flew the drone because it's too dangerous to take people there. And it collects all the digital data, the coordinates, and also the color. And then bring that back to the office, and the geologists use that now to actually look at the rock mapping, the shear faces, etc. Lots of things happening in autonomous vehicles. And then another interesting thing for me is computational design. And a good example this is a 4.5 kilometer tunnel in Melbourne. And what computational design is, instead of going in, you actually just define any parameter here, design parameter once. So what happened on this design is some detail of the tunnel cross-section changed. Now traditionally it would have taken us 3 weeks to get it out. It took them 2 hours to reprint the entire design. Because you just go in here and you change one parameter, whether it's width, length, flow, temperature, whatever. And it applies it to the whole 3-dimensional model. So computational design is absolutely currently a big topic in our industry. Another one that's automated is clash detection. As an example, historically in the construction industry, this costed us a huge bundle. Is you were designing the HVAC, the air and the water, and you didn't realize that the two will be clashing. and then on site they realize it's clashing, and then they have to figure out what they do with it. Nowadays the computer will do clash detection. It'll tell you you've got to reroute when you put in the water function because the air will come. Also on construction sites now, no more drawings and paper, it's all iPads and computer screens. And you can actually page through a design or look at from any side or any direction. This is two guys from Sasol, just again showing you the power of what they do.
Ja, maar ek wil net weet presies daarso. Okay, so also moet
Hier's
ons
nou iets op my plaat. Ek gaan nou soontoe hop en dan gaan ek terug daar.
Okay.
Hierso. Nou kyk, sluit, né?
Dis reg ja.
Nou loop hierdie kabel rakkie op. Nou hier, maak nou point.
Daar's 'n probleem.
Hoe sit jy 'n kabel daar in?
Nou loop ek hier agter toe.
All right, so it's real, guys, it's real. All right, I'd like to move to this, the third part of the presentation, which is about the impact on the role of the engineer. To me, I'd like to start off with the definition of engineering, or the engineer. And it says, engineering is an art form where you use your imagination to solve a problem or create something, and it's based on maths and science as building blocks to make the frequency of your imagination come to life. Probably what I realize is that engineering needs both of these things. We need to have a solid understanding of maths and sciences, and then I'm of opinion in the future we're going to have to do much more of this, solving problems and be creative. In some way our disciplines has become so focused on maths and science that we've lost our ability to innovate. We've lost our focus on interaction with clients and with humans. And what I'll show in the next few slides, I'm of opinion that if we really start thinking about the fourth industrial revolution, most of the things engineers do is repeatable. And anything that you can repeat, a machine can learn. So somewhere I believe that we'll have to start saying, well, we can't do without this, we've got to understand it, but we've got to move our skill base and our application much more towards solving problems, complex things, talking to people, interacting with society. I'll show you in the next few slides why I think that. We're having more and more apps that's commoditizing what we do. For the last 20 years, I've got a degree on the wall, and it taught me how to do structural design. Nobody can take that away from me. That's gone. Now you can go and find an app that can do that. All right, so the future is going to be different from the past. And apps can be very valuable. They can save us time. They're also dangerous, obviously, in the wrong hands. The digitization is giving us a lot of new communication tools, and I'll show you an example here. This is in Dubai. Right here, one of the solutions that they were considering is a bi-directional part of the highway, and it's impossible to do this without visualization to convince a client that this is feasible. Now, where I think these things are of great assistance for us is that our industry is known to be very distant from society. We are solution-driven. We know how to do these things, but we're not necessarily good communicators. These tools will help fill a lot of that gap in terms of addressing, taking people on the journey, as the example I've just shown. The role of the engineer, humanistic-centered designs. It's about interacting with non-technical clientele. There's a whole world around increased efficiency, and it's about this. Historically, what did we do? Is we did an original design, printed it out on paper, and gave it to a contractor who punched it back into Excel and all other tools to do a price, and then printed it out again. And by the way, right here, at the peak after the construction is done, we basically gave the client a roll of paper the design instead of saying here's a digital model. So all of these are inefficiencies that in future can be taken out of our designs. Social media and social interaction, all of our kids and the youth are absolutely digitized. That's the way they will communicate. All right, now the World Economic Forum identified the top 10 skills needed in 2020, which is only 2 years away. They talk about complex problem solving, critical thinking, creativity, people management, coordinating, emotional intelligence, judgment, decision making, service orientation, negotiations, and cognitive flexibility. What I find fascinating of all of these is this is the stuff that computers can't learn. But this is the attributes that the next generation of engineers, and even those that still got more than 5 years left of their career, will have to be good at. And I can see this combination of saying, well, let's use digitization, digital tools to fast track and make things easier for us, and then put our focus on these skills to have a better offering to society. I think it's got to be founded on engineering. You've got to have the mathematics and science knowledge and understanding to truly fulfill the objective. I think it's going to be much more about being a humanist as well as a technologist. It's going to be about system thinking, designing for people, storytelling, innovation, curious, and being ethical. And most definitely digital. In our practice, we believe that any engineer that's not digitally savvied will have less than 5 years of career left. That's how critical it is. The ideal is for somebody with deep technical experience that's not afraid of this stuff and use it. For example, computational design, instead of just having one design, it's possible for us now to really look at the optimal solution. Because through computational design, you just change 1 or 2 parameters and you get to optimization. T-shaped practitioners, what's implied here is to say that it's got to be individuals with deep technical skills and then the ability to communicate and interact. Unconventional holistic thinkers. So my closing thoughts, ladies and gentlemen, is that I believe that we'll have to dance with disruption. We've got to keep on changing our steps because the world is changing. We have to embrace digital as an imperative and an opportunity. And I actually think that the fourth industrial revolution is an opportunity to digitally transform, and that will help us to reposition. I actually, when I wrote up my abstract, I was talking about engineering. I think, Cheryl, you're absolutely right. It's much bigger than this. It's also allow us to transform society. Interesting, there's a recent book by Charles Handy, which is a person from the UK. He talks about the segment sigmoidal curve, about society using digitization to change society. So I think you've actually quite right that it's bigger than only engineering. This is my last slide, just some good references for those of you that's interested. And then especially recognition, Professor Kali Pastorius there, the third one on the list there. Kali is recognized as a thought leader in this space. So go read his stuff, it's good. Thank you.